Now we'll talk about lightning. You see some clouds here. What you're seeing is really just the bottom edge of some clouds. Thunderclouds can really be very, very tall, several miles high in many cases. And weather inside the clouds, the movement of air, usually up and down, can cause movement of charge inside the cloud. And you can get a buildup of charge, positive charge, for example, at the top of the cloud, and negative charge down at the bottom. So I'll draw some negative charges here, representing a bunch of electrons built up on the bottom edge of these clouds. And again, this is happening because of weather inside the cloud, movement of air inside the cloud. The cloud has basically become polarized with the positive charge up on the top and negative charge down on the bottom. Now let's draw the ground down here, and we'll put some water over here. And let's put some structures down here. Here's a little house. And we'll put a tree next to it. With some leaves on it. And let's put a car down here parked next to the house. Okay, a couple other things. We'll put a person out here. And let's put a boat in the water. And this guy shouldn't be out sailing in the storm, obviously. Okay, the negative charge on those clouds has an effect on the ground beneath it. Remember, we talked about charging by induction. The same thing happens here. On the ground, there are positive charges and negative charges. And the positive charges are from the protons, which are stuck in the nuclei of the atoms. The negative charges, the electrons, are much more easily moved, and they're repelled by all the electrons in the clouds. So these electrons tend to get pushed away. They get pushed deeper into the ground or spread out by the negative charge in the cloud above. So the ground beneath now has been charged by induction. The ground is positively charged. And all the things on the ground are positively charged. The tree gets positively charged. The house gets positively charged. The car, even a little bit. The electrons don't really move out of the car very easily because the car is sitting on rubber tires, and the electrons don't flow through the tires very easily. So the car probably won't develop that much positive charge, but the person on the ground will develop some positive charge too. Now, when something is charged, the charge tends to concentrate on the corners and the pointy parts of an object. So it's going to be the corners of the house up here and the treetops, the tips of the limbs, that develop a lot of positive charge. This is also going on in the water over here. Electrons are repelled through the water, and the boat becomes positively charged, and the tip of the mast up here in particular becomes very strongly charged, all the little pointy parts. And if you're out in open land, this is a large flat area, and you are the one thing sticking up. You are essentially the pointy thing, and a large positive charge will develop on you. Anything sticking up relative to its surroundings will be more strongly charged. Now, the electrons in the cloud are negative, and they're attracted to the positive objects on the ground. And if the force of attraction is strong enough, the electrons will jump across the gap, and that is a lightning bolt. So these electrons come flying down, and each of these is a lightning strike. Globally, around the world, there are approximately 100 lightning strikes per second. And you might think, well, I don't hear a storm at all right now, but somewhere there's a storm. Probably in lots of places right now there are storms. There are some places down off the coast of South America that get about 7 days of sunshine a year. And they're just massive storms. Some of these are over the ocean, some are over land, but there's about 100 lightning strikes per second. That makes lightning the number 2 cause of weather-related death. Flooding is the most common cause of weather-related deaths. Lightning is the second. And a lot of times there's multiple lightning strikes in a single stroke. When lightning strikes, you might see a flash, you might see this bolt flicker. There's several strikes at once right through the same place. And it makes an electrical disturbance that you can actually pick up on AM radio. It will just sound like static on AM radio. If you're driving in your car and there's a thunderstorm, not even over you, but just anywhere nearby, and you're listening to AM radio, you can hear a little static, a burst of static on the radio every time a lightning bolt strikes. And lightning can also travel from ground to cloud as well as from cloud to ground. And it can also travel from one cloud to another. If there's a positive region on one cloud, say this cloud is polarized this way, the negative charge has built up over here, you could get a lightning strike from one cloud to another. You can also get a lightning strike within a cloud. And what people call heat lightning is really just a regular lightning bolt. You might have lightning that's really far away, too far away for the thunder to be heard, and often you see the light reflected off the clouds or the glow of the light through other clouds between it and you. But there's a lightning bolt in there that's causing the glow. So what people refer to as heat lightning is typically just regular lightning. Now, in addition to striking these areas where the positive charge is concentrated, that's obviously the best choice for a target. Lightning's attracted, the negative electrons are attracted to the positive charge, so it's going to go toward the places where the positive charge is most strongly concentrated. But there's another thing going on as well. Lightning seeks the easiest route to the ground. And just as water doesn't flow straight down a hill, it will wind down the hill, finding the easiest route to the ground. The lightning winds through the air, and that's why you see the bolts aren't perfectly straight. The atmosphere, we can't see it, but there's different pockets of air at different density and different temperature and different humidity, and the lightning is winding its way through that, finding the easiest route to the ground. When the lightning comes over here to the tree, for example, it's going to go through the tree rather than beside the tree. Even though the wood isn't a good conductor, it's a better conductor than the air over here. So the lightning, seeking the easiest route to the ground, will go through the tree. And all this negative charge is then dispersed through the ground and neutralizes the positive charge in that region. But it seeks the easiest route to the ground. And you, if you're standing out here, you are a better conductor than the air around you. So the lightning will prefer to go through you rather than beside you. And you don't necessarily want to stand next to a tree seeking shelter either. If there's a tree over here and you're trying to get out of the rain and the storm, remember the tree is a good target for lightning. And this tree will be positively charged, and lightning will be more likely to strike the tree than the ground next to it at a safe distance. And if lightning strikes a tree very close to you, it can still be deadly. Even if it doesn't hit you directly, it can still kill you. And there are stories of people getting killed in situations like this. Golfers, for example, out in the middle of a golf course and a storm comes up, and so they go hang out under a tree waiting for the storm to pass. Lightning strikes the tree, and people have died on golf courses from that situation. A car, though, is pretty safe. It's a pretty safe place to be inside a car. And it's not really so much because of the rubber tires. Lightning could still strike a car. But in seeking the easiest route to the ground, lightning's going to go through the metal exterior of the car because metal is a very good conductor. And so the lightning could go through the metal of the car and then jump to the ground, leaving the occupants of the car untouched. So you're really pretty safe inside a car from lightning, even if lightning were to strike the car, which isn't as likely as striking something sticking up much higher. But even if it were, you're still safe inside the car.